And so if we're going to talk about all the elements, we better have a handle on how many elements there are. So how would you deal with that?
We could use some variable, I guess, to represent the number of elements in the vector, say n.
Okay.
That might work.
And are there any limits on the value of n?
No, I don't think so.
Well, it better be non-negative, right?
Right.
It wouldn't make sense
yes.
to have a vector of negative length. So we're going to, when we talk about all the elements, and the typical element is going to be in the ith position, the value of I is going to go up to this value of n. And of course, with programming languages, you have to worry about whether they start counting from 0 or they start counting from 1. Mm-hmm. Here we'll say that we start counting from 1. That is, the first element of the vector is in position 1, and then the subsequent elements go up to the last one being in position n. So if there are n elements in the vector, and we're talking about all but the last, okay, that says we're talking about from position 1 to n minus 1.
Right.
Okay? And we want to have some property that's true about that. And you said that the property was that if we look in that position and get the value in that vector, it's less than or equal to the value in the next position.
Correct.
Okay? So if we're going from 1 to n minus 1, and n is initially 0, isn't that asking us to look in the position minus 1?
I thought we said that n, well, I guess n can't be negative, but we're looking at, well, couldn't we write it in such a way that we say I and then I plus 1, so we could start at 0 and then go to 1?
Well, I think we have the same problem there. But
okay.
what we're trying to do is make some statement for all I, I being from 1 to n minus 1. If n is 0, then we're saying from all I from 1 to minus 1, and there aren't any I there. Right. So vacuously, it's true. Okay? So even though we run into this seemingly nonsensical situation, it doesn't actually affect the truth of the postcondition. Okay? So think about that a little bit. And given that, we're then allowed to make this quantified statement for all I from 1 to n minus 1. And what must be true of each of those I minus 1 I possibilities? We're talking about the output.
This doesn't get any easier. We got to be precise. Okay, so y of I is less than or equal to, or no, because we're doing I minus 1. So it's going to be greater than or equal to y of I minus 1.
Now, I think you had it right the first time. So if I is starting at 1, okay, and then we're going to be talking about, and we're going to n minus 1, we're going to be going to y sub I plus 1.
Okay.
Okay, so you might want to change your slide there. Okay, so what it means to be ordered is if we look at the first n minus 1 elements, any one of those, and compare it to the one next to it, okay, next to it on the right, okay, it's got to be less than or equal to it. And if we have that property, then we say that the output is ordered. Notice that we didn't say anything in this part of the postcondition about what those y's are and how they relate to the input. That's what the second part of the specification is.
Before we move forward, is it okay to start trying to express things like this is kind of like predicate calculus kind of notation? Is that what we'll be leaning towards once we start writing or expressing things in OCL?
So in this part of the lesson, we're going to use first-order logic. It turns out that OCL is just another syntax on top of first-order logic. Okay, we're going to stick with first-order logic here. Eventually, I'll show you a little bit of OCL, and then in later lessons, we'll get into the whole OCL as a language, which, in addition to first-order logic, has some other things that help it deal with UML.